Good morning, guys. I'm here to walk you through the quantitative analysis and chemical bonding lab. In this lab, we're basically going to be observing physical properties of different substances and then using what we know about bonds that form between different types of atoms and the strength of those forces that hold those particles together. We are going to try to identify several types of substances which we do not know the identity of. To start, we have a practice where we're going to be observing and recording different properties of each of the 4 types or classes of general bonding that we've reviewed. So that includes ionic, polar covalent, nonpolar covalent, and metallic. And as you guys can see here, if I try to move this a little bit down and a little bit over, there we go. I have the first part of the lab already set up. So I have spot plates for each substance. I'm going to be conducting about 8 tests per substance within the spot plates, and then some other tests like melting point and conductivity of the solid outside of the spot plate. You can see I have dextrose, copper 2 sulfate, paraffin wax, and zinc. I have some water that I'm setting to boil. I have my aluminum tins, which I'll be testing melting point with. And then I have a variety of solvents that I'm going to be checking solubility for. Okay. So we can start here with dextrose. As you can see, dextrose is a white crystalline solid. In my first test, I can check for conductivity. This is a conductivity meter. You can see if I test it with something that is a metal, you can see that the lights go on. I know maybe it's hard, but they go on. All right, so metal is a known conductor, so I know it works. I'm going to put this in solid dextrose, and you can see that the lights do not illuminate, which means that as a solid, this substance does not conduct electricity. In the second test, I'll be looking at the solubility in water. So I have some deionized water. I'm going to add some water. And it dissolves. I'm not sure if it's possible for me to show you this or not, but I'm going to make an attempt at it without spilling it. And I don't know if you can see in this well that it has completely dissolved. In my next test, I will test conductivity of the solution. None of the lights illuminate, so there is no conductivity. In my next test, I will continue to take solubility tests. And in addition to that, since I already have this solution dissolved in water, I'm going to go ahead and do pH. Down since it's boiling. I take my pH strip and put it in the water. I look at my pH strip, and if I want to, if it actually changed colors, I could compare it to the colors on here, except it hasn't. The pH here is roughly neutral. It is about 7. Okay. To continue with my tests, I'm on to solubility now. So I'm going to check the solubility in hexane, which I have here. Hexane, if you don't already know, is a nonpolar solvent. Added my hexane. And honestly, it does not look like it's dissolving. Although it's difficult to see, and I'm not even going to bother to show you, you're not going to be able to see the white crystals against the white spot plate, but I can see it, and it is not dissolving in the hexanes. I'll go on and I'll test my polar solvent, my polar organic solvent, ethanol. And look at this. I still see some crystals, but not as many. I'm going to go ahead and say that this is slightly soluble in ethyl alcohol. Now I'll do reactions. I'll add 1 molar HCl. And I see no reaction. I'm just trying to decide if it actually dissolves. And it might, because this is water-based. Giving it a minute. I can say that it dissolves, but that it does not react. Now we'll try our base. There's a similar result with the base. There's no visible reaction, but I can see that the crystals are dissolving, and that makes sense because it's a water-based solution. The last thing I'm going to try to do is set this back to a boil and test the melting point. So what I will do is I will add a small amount of the solid to my dish. And sit it over the boiling water. Although the vapor that comes off is going to be greater, a little bit greater than 100 degrees Celsius, what we can say here is that the solid either melts at under 100 degrees Celsius or melts at over 100 degrees Celsius. So in this experiment, in this setup, if we observe it melting, then it melts at 100 degrees Celsius about or less. And if we do not observe it melting, then we can say that it melts greater than 100 degrees Celsius. Remember that substances with weaker molecular forces tend to melt at temperatures less than 100 degrees Celsius. So I'm going to let this go for a minute. And see what we get. Okay. In the meantime, I'm going to start my tests for copper 2 sulfate. First, I'll observe it. You can see it's a greenish blue powdery substance. I'll test its conductivity as a solid. I'll make sure my conductivity meter works, and it does. And as a solid, it does not conduct. Next thing that I'll do is I'll start to check its solubilities. I'll start with its solubility in water. Give it a minute. Do a little stir. And as I'm stirring it, I can see that it completely dissolves. I don't know if it's possible for you to see it or not. Okay. It completely dissolves. What I'll do next is again check its conductivity. And when I put it in solution, the conductivity meter lights up, so I can say that it conducts electricity in water. Okay. The next step will be solubility in different solutions. I'll start with hexanes. Mix it. And nothing is happening. I'll try ethanol. I'll mix it. It looks like it could be slightly soluble at best. There's a little bit more in here. Taking a closer look at it, I'm going to go ahead and say that it's insoluble in ethanol as well. The last thing I'll do before I check its melting point is check its reactivity in an acid and in a base. So I'm going to add my acid. mix it up. I see no visible reaction, but the crystals are clearly dissolving, which again is not surprising because it's water-based. Okay. And then I'll check its reactivity with the base. When I add the base, I get the formation of a precipitate. Which you can see clearly in the front. Okay. I'm ready to do my melting test. This, nothing happened to. So for dextrose, I can say that it has to melt at a temperature above 100 degrees Celsius. Let's try a little bit here with the copper 2 sulfate. And just going to try to spread it out. I'll let it sit, and I'll do my other tests. My next test is going to be for paraffin wax. Here's paraffin wax. You can see that it's tiny balls, and it's kind of, I don't know, opaque and white. I guess you could describe it as waxy. It is a wax. The first thing that I'm going to do is check its conductivity. So I check my meter and it lights up. And I will put it in this wax and nothing happens. It is not a conductor in the solid phase. The next thing that I'm going to do is check the solubility of the wax. I'm going to start with water. Add enough water. I'll even give it a minute. Try to push the wax around, and nothing is happening. There is no solubility in water. I could test its conductivity, but if it doesn't dissolve in water, then it's not going to produce any particles, so there's no bother for me to, or there's no reason for me to bother to check it. It will not conduct electricity. The next thing I'll do is I'll check its solubility in different solvents. I'll start with hexanes. I'll add hexane and I'll give it a moment. And while I'm giving it a moment, I'm also going to add ethyl alcohol so that it has a moment. Might have to give it more time. I'm going to try to break it up. hexanes, it actually looks like it's getting smaller in size. I'm going to give it a little bit more time. It's totally possible that there's not enough hexane in this spot well to dissolve it. So I'm just going to try to monitor its size. I'm also going to try to do something similar over here. For ethanol. I'll mix it a little bit. I'll give it a little bit of time. And I'm giving it some time. I'm going to try the reaction with the acid and with the base. I'll add my acid. It's water-based. Not really expecting much here. Same with the base. It's water-based. Continuing to monitor what's going on here in the hexanes, and it definitely looks like the paraffin wax is changing. It's getting smaller. I'm going to go ahead and say that this is what it looks like if it's dissolving. And here, definitely also starting to dissolve in the ethanol. So we can say that it's slightly soluble in the ethanol and soluble in hexanes. I'm going to go on and check its melting point, but you can see here for copper 2 sulfate, nothing has happened. So its melting point is definitely greater than 100 degrees Celsius. I'll add a few of the pellets of wax. And I don't even have to wait, it's already melting. You can see it's melted. So this clearly melts at a temperature that's less than 100 degrees Celsius. The last substance that I'm going to test is zinc, a metal. I'm going to check my conductivity meter to make sure that it's on. Check the conductivity of the solid, if there's enough in here. And I have to find a piece that's big enough that both of these electrodes will hit it. And it's very difficult to see because I'm trying to get it on the camera, but when I do get them both on a piece of metal, there we go. It is lighting up. It does conduct electricity in the solid phase. I'm going to quickly move through the remaining tests here because I think we know what the results are going to be since it's a metal. I'll add some water, but of course it will not be soluble in water. And since it's not soluble in water, I'm not going to bother to check for conductivity. I'll check solubility in my nonpolar solvent. And I got nothing. In my polar organic solvent. As expected, nothing. Then I'll check reactivity with acid and with base. when I add the acid, see some bubbles that are forming. Zinc replaces hydrogen, and hydrogen gets released as bubbles. It's hard to see because there's really not a lot of metal in here. I don't think you can even see it, so I'm not going to show the camera. But I will tell you that it is happening. I'll check its reactivity with the base, fully expecting that nothing will happen. And nothing does happen. Lastly, I'll check its melting point, but I think we all know that nothing is going to happen here. In fact, I think I'm just going to add a single pellet. We'll let it sit. I could let this sit forever and there will be no observable change. This definitely melts at a temperature greater than 100 degrees Celsius. Hey guys, I'm back here and I'm getting ready to test for all of my unknowns. And you can see I've set up my spot plates. And although I have only 4 wells in each spot plate, I'm actually able to carry out more than 4 tests. So to let you know the tests that I am going to be carrying out, I'm going to check for their conductivity as a solid, which I don't need a well and a spot plate to do. I'm going to check for their solubility in water. I'm also going to check for its conductivity in water, as well as its pH in water. I'm going to check for solubility in an organic solvent, like hexane. And I'm going to check for its reactivity with the base, where I'll be using a pH strip before and after, because some of these are acids. And I'll also be checking for the reactivity with an acid. Because none of these are bases, there'll be no acid-base reaction, so I don't necessarily have to check for pH. But maybe, knowing my characteristic reactions of certain substances with acids, I could be on the lookout for some bubble formation. You can see that I have these 12 unknowns out. If I had to describe them, unknown 1 I'd describe as a white crystalline substance, a solid. 2 most certainly looks like a metal. It is shiny, silvery gray, solid. 3 is, I'd describe it as white, but powdery solid. 4 is kind of a viscous, colorless, clear liquid. 5 looks to be another white crystalline solid. 6 is a dark gray or black powdery solid. 7 is a reddish orange powdery solid. Oopsies, looks like I have 8 and 9 backwards. 8 is like a granular gray solid, maybe powdery. 9 is a white crystalline solid. 10 is a white powdery solid. 11 is a shiny blue-gray solid. Also kind of looks like it could be a metal. 12 is like an eggshell, like an off-white powdery solid. What I'm going to do now is take a break and carry out some of these reactions. And when I come back, I'm going to share my results with you. Alright guys, I'm back. And what you can see is that I've done solubility in water, and I've also tested the pH of the solution. So to describe solubility first, number one, I can describe as being slightly soluble in water. Number two, as I said, I didn't bother to test. Number three, I can also describe as being slightly soluble in water. Number four is not soluble in water. Number five is soluble in water. Number six is not soluble in water, as you can see, and neither is number 7. I know that number 8 and number 9 are mixed. Number 8 is not soluble in water, and number 9 is soluble in water. For number 10, I can say that it's slightly soluble in water. Number 11, again, I didn't bother. And for number 12, it is very soluble in water. You can also take a look at the colors of these different pH strips. You can see that in solution, number 1 is an acid. Number 3 is slightly basic. Number 4 and 5 and 6, 7, 8, and 9 are neither acidic nor basic. They are neutral. Number 10 is acidic, and there's number 12, basic. Now, as I said, we have 2 basic substances here, but when we started, I had looked at the chemical formulas, and from those chemical formulas, there are no traditional bases, meaning I didn't see any chemical formulas that had hydroxides in it. We are going to study substances that can behave as acids and bases a little bit later on in the year when we get to applied units, and you'll understand why some of these have basic properties even though they're not hydroxides. Alrighty guys, I'm back. I've checked their solubility in the nonpolar solvent, and none of them were very soluble. Only number 4 was maybe slightly soluble. I also checked their reactivity with a base. Now a base looks like this, or my base alone, you can see there's a strip laying on top of the cap, is very blue. Alright, so that dark blue pH indicates that I have a base. When I added a base to a solution of number 1, you can see now it went from being acidic to being neutral. Nothing happened in number 3, it's still basic, and same with number 4. However, you can see that in number 5, it's getting less basic. So that means number 5 must have also reacted. Nothing for number 6 or number 7. Nothing for number 8. And nothing for number 9. Number 10 had a slight reaction. You can see that it's green in color and not blue. I didn't check number 11 because it doesn't dissolve. And number 12 continues to be a base. I really didn't even have to check that one. Last round of tests will include conductivity as a solid and reactions with an acid. I'm back. I've checked my conductivity, and I found that unknown 2, unknown 6, unknown 8, and unknown 11 all conduct electricity. So there's 2, there's 6, there's 8, and 11. I've also added acids to each of them, and I found that the only ones that reacted with an acid were number 2, number 3, and then at the end, number 12. Both number 2 and number 12 produce bubbles. Actually, so did number 3. Alrighty guys, this does it for the lab. I hope that you have been able to record all of the results. If you've missed anything, all of the results for all of the tests for all of the unknowns can be found in the PowerPoint, which I've attached to the lab assignment. You should be able to use the results of those tests to correctly match an unknown to its identity. All of the labels, meaning the labels that would be on a bottle for the unknown substances, which includes its molecular or chemical formulas as well as its name, can also be found on the PowerPoint, but this at the very end. I hope you guys enjoyed it, and I will see you in class.